So the other day we were looking at a fossil dig. We looked at two different layers. We talked about what a fossil was. A fossil is a trace of remains of a living thing that died a long time ago. And we looked at the different two layers that went with our friend Doug, and we figured out some.
I finished with that, I remember.
Yeah, but you need to pay attention because you're going to listen. It helps with today's stuff. So we looked at different characteristics of each type of fossil in each layer. So there were two layers. There was a higher layer that's closer to like where we're standing, and then there was a lower layer that is older. The lower you go, the older the fossils are. The higher you go, the younger the fossils are. That's just how, because if sand keeps stacking up, everything under it is getting older. Now, we looked at this first fossil. This looked like a monkey of some type because we had some characteristics of a long tail. We had long arms and legs. We also, if we looked at the hands and feet kind of look very similar to one of a monkey. And then we looked at the characteristics of the second fossil, which if you look, it has winged arms. It looks like a winged tail, as well as long legs that look like they only have two, would you call them fingers? What are they? Talons. Talons. That's a good word. And then we looked at the third one, which we obviously know is a dragonfly. So what type of animals are these?
Monkey, dragonfly, don't know.
Right, but what type of animal are they?
Land.
They're land animals, okay? Because if we look at our second layer, we look and we see things such as a seashell, we have a starfish, and we have what looks like a skeleton of a fish because it has fins, has a tail, so has the spine. So we realized with Doug, because this was Doug's dig, he figured out, because he was from Illinois, which is nowhere near an ocean, but we figured out that the lower he went, they found more ocean animals. So that means at some point, Illinois was underwater. At some point. We don't know when. We just know that long ago, because it's further down in the ground, there was ocean where Illinois is. But now it is fields and grasslands, and so it has different types of animals and their different traits. So we're going to look at specifically looking at dinosaurs today, trying to figure out characteristics that help us to figure out what do these dinosaurs eat. And same thing. Did I just copy the same thing? No. So we're going to do another mystery science lesson. It will tell you what to do while we're doing it. So you need to pay attention to the directions.
So are we just watching?
You have this paper.
Oh, we do?
Yes, it's one of the papers that I gave to you before you left.
Oh, yeah. And then I was so confused why we ate them.
Back up the deck. Keep going. So it'll tell us when I need to give you this paper. This is the paper that looks like this for that. Well, actually, for those that are online, this is the paper that you'll be eventually needing. So if you need to go get it, this is your time to go get it. I'll give it to you in just a minute. All right, so let me get my side ready over here.
When you think of fossils, you think about
on closed captions.
Dinosaurs. Dinosaurs are exciting. Some of them were huge, like this Brontosaurus, a member of the sauropod family of dinosaurs. Those are the dinosaurs with the big legs, the long necks, and the long tails. It's actually one of the sauropod dinosaurs that's the largest land animal ever to walk on Earth. That's this one, called Dreadnoughtus. Here's how big Dreadnoughtus would have been compared to an adult human being. And you know that some dinosaurs were absolutely terrifying. Like this one, the most famous dinosaur of all, Tyrannosaurus rex. Each of its ferocious teeth were as big as your hand. This is a real fossil T-Rex tooth right here. Now, you might have heard that all of these great beasts died out a long time ago. We say that they went extinct. Scientists have reason for thinking that they all died out about 65 million years ago. One theory as to why they went extinct is that an asteroid, a rock from space, slammed into the Earth. Another theory is that a lot of volcanoes started erupting. Scientists aren't totally sure which theory is correct. What we do know is that the dinosaurs, these incredible animals, were all killed off, leaving behind little more than fossils of their bones. People are fascinated by the idea of dinosaurs. Because no one has ever seen them alive, as soon as the first dinosaur bones were discovered, we put them together, and we tried to imagine what would these animals have looked like on the outside. Ever since the 1800s, we've been imagining what dinosaurs must have looked like. Here's one of the earliest attempts to imagine dinosaurs. These are statues based on the fossil bones of a dinosaur called Iguanodon. Now remember, no one had ever seen a dinosaur on the outside, but this is what we imagined they looked like. In the early 1900s, the first movie projectors were invented. And one of the great things about movies is that you can create otherwise impossible things using special effects or animations. Do you want to guess what impossible thing one of the very first cartoons tried to bring to life? You guessed it, a dinosaur walking around. It was an animation from the year 1914, one of the very first cartoons ever, called Gertie the Dinosaur. How did we decide to make a dinosaur look in the first movies? Well, I thought you might like to see a short clip from Gertie. Here it is. Since the time of this Gertie dinosaur cartoon, we've gotten a lot better at making animations and special effects for movies. By the 1990s, people were amazed at how lifelike the dinosaurs looked in the movie Jurassic Park. Jurassic Park is probably a movie your parents remember vividly because it's also meant to be a scary movie. Now, did you notice how whenever we've imagined what dinosaurs look like, we make them look like giant lizards? Do you see here? We give them scales, just like a reptile. Why do we make them look like reptiles? Why do we give them scales? You might think, well, because that's how they looked, isn't it? But do you really know? I mean, what makes us think they had scales? Think about how we find dinosaurs. We find them as fossils. When we find a dinosaur fossil, it's not like there's any actual flesh. That's not left. They didn't die last week. They died 65 million years ago. Any flesh has long since rotted away. All we have of them are bones, right? So why assume they were scaly reptiles? How do we know they weren't more like this? Furry beasts that look like King Kong. Given that all we have of them are fossil bones, why do we think dinosaurs look like lizards? When scientists look at the bones of a dinosaur, why do you think they decided the outside of the dinosaur looks like a lizard rather than some kind of furry animal?
So when scientists look at bones of a dinosaur, why do you think they decide the outside of a dinosaur looks like a lizard rather than a furry animal or feathered animal? What? Because it has what? Skin? Is that what you said? I can't hear you. You gotta say a little louder. Scales?
Which is they are a type of giant lizard, but they're actually a reptile that eats meat or a carnivore that eats leaves.
Okay. All right, Gabby?
Because when they find the fossils, they see like little spikes things from the dinosaurs, and they might think that those are scales.
Okay. All right, Christopher.
Because they look like a lizards.
Maybe they look like a lizard. All right, so let's reveal the answer. Scientists noticed some important similarities between dinosaur bones and today's lizard bones.
That's what I was gonna say. Like their skeletons look similar.
That's Jody.
Oh, I'm sorry, I wasn't reading the passage. Is that right?
When you look at the bones of an animal, that's just showing you the inside of it. Bones can't help you know what an animal looked like on the outside. You know, whether they had fur or scales or feathers. Or can they? Could you use bones to actually tell you what an animal looked like on the outside? There are some scientists who collect and study bones. Bones of all kinds of animals. Cow bones, chicken bones, snake bones, lion bones. Now, to you or me, these bones just look like bones. But to someone who loves bones, someone who studies them, they have noticed some very interesting clues. Take this one. To us, this is just some kind of animal skull. But to a bone expert, they look at this and say, nope, this isn't just any animal skull. This is the skull of a scaly lizard. How can they tell what kind of animal it is just from its skull? Well, I'll let you in on one of their little secrets. It's these openings in the skull. That's something special. See, the furry animals, mammals, animals like horses, squirrels, cats, and gorillas, their skulls have openings where you'd expect them. The eyes, the nose, the mouth. But the scaly animals, reptiles like iguanas, geckos, and other lizards, they have openings in other places on their skull as well, places you wouldn't expect to find holes. Here's the eyes, here's the nose. Those are places you'd expect to find holes. But see here and here? Those are extra openings in the skull. Openings that mammals don't have. So just by looking at a skull, you can tell whether something is a lizard or not. The very first dinosaur bones
Alex,
were
we're in the
discovered
middle of a
about
lesson,
200
sir.
years ago, in the early 1800s. When people started finding dinosaur bones, they wanted to know, what kind of crazy animals are these? They're huge. They're unlike anything we've ever seen. But they're just bones. So can we get any idea what these animals might have looked like? So what do you think one of the first things scientists looked at? They paid close attention to the skulls. So when scientists find fossil bones, they look for whether the animal has just the expected number of openings in their skull, like furry mammals, or extra openings in the skull, like scaly reptiles. I'll show you some skulls, and you decide. Are they skulls more like lizards, or skulls more like mammals?
So what do you think? Does this dinosaur skull look more like that of a furry animal or more like a skull of a scaly lizard? And why do you think that? All right, Kalani.
Okay, this holes, and I think it's a lizard.
Okay, because of the hole, do you think it's a lizard? All right.
Because mine are lizard people.
Gabby?
I think all we've known about dinosaurs is like they're lizard-like. I think they're lizard-like.
Okay.
This is what I'm saying.
Yes, they have similar traits to a lizard. Christopher?
Because I think they're a lizard type because you don't know if dinosaurs can be fluffy or lizards, so I think they're lizards.
Lizard, because we just talked about how it has the nose hole, the eye hole, and it looks like there's some other holes that we have to take into account. Sebastian?
The skull looks like one, not just like one of the lizards.
Okay, yep.
That's a
It's got that long
lizard.
nose looking thing, the mouth Looks like it goes all the way from the jaw all the way up to the front of the nose. So that's a characteristic that it has. Yes, Alex?
Were the government dinosaurs? Because dinosaurs are lizards,
We're not.
and the government is a lizard.
Alex? Alex? No. Question number 2. Here's another dinosaur skull, the Allosaurus. Does it look more like that of a furry animal or more like the skull of a scaly lizard? Jaden? It look more like a furry animal or one of a lizard? Ava? Right, there's more holes. Look at the neck of it. You can kind of look at the neck and see that it's got a longer neck. Okay.
The word dinosaur itself comes from something you just learned about. It's actually a combination of 2 words, both from the Greek language. Those words are dino, which means terrifying, and saur, which means lizard. So dinosaur means terrifying lizard. Dino, the terrifying part, is because the bones were clearly from gigantic creatures. And some of them have some pretty ferocious looking teeth and claws. The saur part of dinosaur, now you can understand, is because when scientists looked at the bones, such as the skull, they thought, hey, this looks a lot like a lizard. But are you convinced dinosaurs were scaly lizards? I mean, the skulls are just one clue. That's one piece of evidence. How do you know dinosaurs weren't the one kind of animal that had skulls like a lizard, but instead maybe fur like a mammal? It'd be nice if there were more evidence than just the skulls. Well, there is. A few decades after the first fossil dinosaur bones were found, someone found these. Can you tell what these are? It turns out it's not true that fossils are always just bones. Sometimes we get fossils of other parts of animals besides just their skeletons, besides the bones. Any idea yet what these round lumps are? If it helps, these were found next to a dinosaur's skeleton. Let me show you a different one of these round lumps. Cracked open and close up. That's a tiny dinosaur skeleton inside. This round thing surrounding it is a fossil dinosaur eggshell.
That's cool.
So you see, this is a fossil nest of dinosaur eggs. Isn't that amazing? Here we have proof from fossils that dinosaurs were a kind of animal that laid eggs. Now think about what kinds of animals today lay eggs. Do mammals lay eggs?
No.
Horses, dogs, cats, chimpanzees, the
No.
animals with fur. No, these animals don't lay eggs. But do reptiles lay eggs? Oh, you bet, see? Here's a picture of a baby gecko hatching, baby lizard, baby crocodiles, baby snake. Here you can see some baby iguanas actually coming out of their eggs. So if there's any chance that dinosaurs might have been giant furry mammals, it's looking less likely now, isn't it? The fact that dinosaurs have skulls more like lizards, and the fact that they laid eggs, which lizards do as well, makes it seem like they must have been reptiles. Still though, you could be unsure about how much they were really like reptiles. But then finally, nearly 100 years after the first dinosaur fossils were discovered, some scientists discovered this while digging up some dinosaur bones. What part of the dinosaur's body do you think this might have been? Look closely.
What part do you think it might have been? Vivian? What?
Stomach.
Maybe the stomach? Christopher?
Maybe it's back.
Maybe it's back. Camille?
Maybe like some.
It might have been the tail.
Might have been the tail. Okay, Jody?
Might have been when it fell
Jameson, sit up, bud.
This
Okay, maybe. It says it's the skin. Those are scales. So here's proof that dinosaurs had scales like reptiles do. Based on what you just learned, summarize why scientists think that dinosaurs look like lizards. So why do dinosaurs look like lizards? Ava.
Maybe. Wait.
Huh?
I was gonna say that they look like lizards because they have like long tails. And, like,
Okay, they made their bone structure is very similar. Jody,
they have scales.
what they have scales. Okay, we have evidence that they have scales. Sebastian,
They have it looks like they have the same skin
okay.
as a lizard.
Who raised their hand on the computer? I can't see it. Is it Camille? Can't tell. Nope. What about how they come into the world? They come out of what? Eggs. So that makes them have traits of a lizard.
So all of these clues, the bones, the eggs, the skin, these are the reasons why we think dinosaurs look like reptiles on the outside, even though we don't have any photos or videos of what dinosaurs looked like when they were alive. This is why in movies and paintings and sculptures, artists always depict dinosaurs as looking like giant lizards. It's exciting we're able to figure out what they look like, but there's still so much more that would be great to know about dinosaurs. Like, how do we know what they ate? In all these pictures or movies, we seem to like to show Tyrannosaurus rex attacking things, or we show sauropods munching on plants. Unfortunately, we can't watch them eat because, well, they've all been dead for millions of years. We can't look in their stomachs because the stomachs rotted away, never having turned into fossils. So is there a way we can tell what dinosaurs ate? Yes, there is. It's the teeth. Just like we can compare the dinosaur skulls with the skulls of animals today, so we can also compare dinosaur teeth with the teeth of animals alive today. Animals that eat mostly meat, called carnivores, have sharp, pointed teeth, which help them grab and hold their prey, the animals that they eat. Here's a lion skull, another great example of a carnivore. You can see it's not just their front teeth that are sharp. Their back teeth, called the molars, are sharp and pointed as well. That's great for cutting and tearing meat off the bone. But with all these sharp teeth, they don't really have any easy way to chew and grind up their food. So carnivores usually bite and tear and then just gulp down their food without chewing it much. They have terrible table manners. Animals that eat mostly plants, called herbivores, have teeth that look like this. The front teeth are big and flat. That's good for cutting leaves or grass. And then their back teeth are big and pretty flat as well, which is useful for grinding up the plants as they chew from side to side. What about animals that eat both plants and meat? Well, they're called omnivores. And just like you might expect, they have some teeth that are like those of plant eaters, and some teeth that are like those of meat eaters. Their front teeth are large and flat for chopping through plants. And then behind those, they have these sharp teeth called canines, which are pointy for catching prey. So even though dinosaurs are long since dead, we could look at their teeth and figure out what kinds of food they ate. Practice a little bit here. See if you can figure out whether each of these animals we're going to show you are meat eaters, plant eaters, or omnivores, just by looking at its teeth.
All right, so here is the activity worksheet that I'm about to pass out. If you're at home, you have this because I gave it to you already.
Oh, Bubba. I ate too much honey. I win the poo.
Alex, this is your last warning before I kick you off. paper that I gave you.
Do you have one more?
Yeah.
Thank you.
Don't be filling anything out yet. You're just waiting for instructions. It says, what do these familiar animals eat? To find out, compare the teeth. It says, which skull has pointy teeth for grabbing an animal? Skull A or skull B?
Are we doing this together?
Yes. Skull A or skull B? Has pointy
B.
teeth. B. Alright, it says look at the back teeth. Which skull has flat teeth for chewing? Skull A. And then it says which skull has front teeth that could cut through the grass or leaves? Skull A. Now looking at each one of these skulls. So looking at skull A. It says, what does this animal eat? Plants or meat? Plants. This animal lives on ranches today. What is it?
Probably a goat.
It's not a goat. A lizard lives on a ranch.
Is that a horse?
It's a horse.
Horse and alligator.
Alright.
I knew it was an alligator. The big one.
Yours is
Alright, skull B. What does this animal eat? Plants or meat and fish?
Meat and fish.
Meat and fish. This animal lives in swamps. What is it? An alligator. Or a crocodile. Crocodile, alligator. Alright, so it's a horse and an alligator. Alright, looking at worksheet page 2. That should be the one right below it. It says, which skull has pointy teeth for grabbing animals? Skull A or skull B? Skull A. So you check off A. It says, look at the back teeth. Which skull has flat teeth for chewing? Skull B. And then the third one. Which skull has a beak that could cut through grass or leaves? B. Very good. Alright, looking at skull A, it says, what does the dinosaur eat?
Meat and fish.
Meat and fish. And then looking at skull B, what does this dinosaur eat? Plants.
So if it has flat teeth
It has flat teeth that eats plants.
and does it eat them?
Sharp. If it has flat teeth and sharp teeth, then it eats both plants and animals. Or plants and meat.
What about a beak?
If it has a beak, if it's got a beak with teeth and stuff, then it eats plants. But like a bird eats meat, but they don't have teeth. They just have a beak. Alright, so this is a Tyrannosaurus Rex. It has pointy teeth for grabbing an animal and tearing meat. The other one is a Triceratops. It has a beak for cutting through grass and flat teeth for chewing. Alright, looking at page 3, it says to figure out the answer, look at the teeth. Circle your answer for each dinosaur. So looking at the first one, you're on the back. Turn it over onto the back. Your paper should look like mine. Alright, so looking at that first one, what do we see? What type of characteristics do we see?
Smooth teeth.
Okay, yes, we see a skull. We see smooth teeth, and what else? We're only looking at this first one right here.
We see how it has like a beak, kind of.
It kind of has a beak. So what type of food does this one eat? Plants.
Plant food.
Alright, looking at the one right beside it. It has what type of teeth? Sharp teeth. So it is what type of, is it a carnivore or a herbivore?
It's a
Carnivore. It eats meat.
and fish.
Meat and fish. Alright, looking at the bottom left. Looking at the teeth, what do we think? It's a carnivore, so it eats meat and fish. And then the last one, what characteristics do you see?
It doesn't have like really sharp teeth.
It doesn't have sharp teeth, it has very flat teeth. Looks like it's got a kind of a beak looking or teeth in the front for tearing, so it eats what? Plants.
They have back teeth.
Right, that's showing the flatness of the back teeth.
It's not flat.
Yes, it is. You just can't see it very well. If you look right here, they're pretty flat. There's no like sharp teeth. Okay, like the flat teeth in the back can be a little sharp, but it's not saying that they eat meat. Like we are omnivores. We eat animals and plants. So we have canines right here, these pointy teeth right here for tearing, where our front ones are flat for tearing meat, tearing vegetables, but our back ones are flat because that's where we chew. Like, so we are both plant and meat eaters. They're called omnivores. All right, looking at this one, it says, draw a circle around the sharp teeth that can grab prey. Draw an arrow pointing to the front teeth that can cut through grass or leaves. And then draw a box around flat teeth for chewing. All right, so we're drawing a circle around sharp teeth that could grab prey. So, sharp teeth to grab prey, right here. Draw a circle around that and a circle around this. Then draw an arrow pointing to the front teeth that can cut through grass or leaves. So I would probably point my arrow right to these front teeth right here. And then it says, draw a box around the flattened teeth for chewing. So I would draw a box around these. Huh? Draw a box around the flat teeth for chewing.
Do we do both of the skulls?
Yes. Okay, so let's look at the Heterodontosaurus. It says, I think this animal eats blank. What do you think the animal eats? Ava? Both meat and plants. Because why?
Because it has sharp teeth.
It has sharp teeth and flat teeth. Write that down. And then looking at the raccoon. Says, I think this animal eats blank.
Plant and meat.
Plant and meat. Because why?
Because it has sharp teeth at the top, at the front, and flat teeth at
Flat teeth in the back.
It has sharp and flat teeth.
Yeah.
So it eats plants and meat.
Yes.
But they both do.
Yes. All right. They both eat meat and plants, has pointy teeth and flat teeth. All right.
You cannot outrun a dinosaur.
You never know. Maybe you could.
And you can't run on it, you can unhide it. On Tuesday, I watched Jurassic Park, the first movie in the movie theater,
Mm-hmm.
with my sister, friend, and dad. And now Sunday, I'm watching the second movie.
I already watched the second one.
On Sunday, at the movie theater, playing at the movie theater.
Hello.
Alex.
Oh, shut up, Alex.
Hey, we don't say that word.
It's bad.
Then stand up if you need to.
She's a bad. She's bad.
No. All right.
Picture, Alex. What is
So, what is a fossil?
Phineas.
What is a fossil?
Fossil, it's
It's not just a
Fossil
dinosaur
is
thing, because
a-
any type of animal can be a fossil.
a lot of dinosaurs?
It's not just a dinosaur. Any type of animal can be a fossil. Vivian, thank you for raising your hand.
It goes from an animal that has died.
That what?
Yeah, an animal that has died.
An animal that has died a long time ago. It is a fossil is the remains or impression of a prehistoric life that includes plants and animals. How do fossils form? Ava?
Sand and dirt find stacking up on them, and then the skin like rots away, and it leaves their bones.
Okay, so plants and animals die. They usually leave nothing behind. However, sometimes those living things die in a watery environment and they become buried in the mud. Once the buried skin and muscles break down, leaving only bones or shells behind. Over thousands or even millions of years, sediment builds on top of them and harden into rock. Then, please stop interrupting me. Then something like erosion brings the remains to the surface where scientists called paleontologists can dig them up and study them.
I know what feeling.
Well, I just told you what it was. What does it mean when something is extinct? What does it mean when something is extinct? Christopher?
It does not exist.
It doesn't exist anymore. Sebastian? It's not living anymore. Ava?
Something that died long ago and it's not alive anymore.
It doesn't have to be long ago. Jody?
It's no longer living or
So if something is extinct, there's nothing else of its kind. Meaning, like an animal could be in danger of it being extinct, like the rhino is on the endangered species list, because if the last little bits of rhinos die, there will not be any more. That means it is extinct. It means a plant or animal that is extinct could once be found living on Earth, but now is gone. It no longer exists. And then what is a paleontologist, Jameson?
Paleontologist is like a scientist that really studies bones.
All right, so paleo means a long time ago, and tologist or ologist is the study of. So it is the scientist who studies fossils. Very good. All right, we're going to watch a quick video.
You say quick, but it's 13 minutes long.
Yeah, well, we got time for that.
Wait, how the...
All right, paying attention, please. No.
Hey guys.
Hey Zoe. Hey. Nice makeup. Who did that?
And how thick was their blindfold?
Haha, very funny. It's not makeup, it's dirt. I was digging around in my backyard when I found this.
Wow. Looks like a shark tooth. Or a saber tooth.
like a banana.
A saber tooth shark.
Awesome.
No, there's no such thing. I think this is from a saber-toothed cat. It's like a giant tiger that lived thousands of years ago.
You mean to tell me I found something thousands of years old right here in my own backyard?
That's right. That makes that a fossil. I'm Dr. Jeff Vinegar, and today we're going to explore the science of fossils and extinction. We'll discover that a fossil is the remains or impression of prehistoric life. We'll explore animals that once walked the earth but are no longer around today. And we'll learn that fossils provide evidence about past life and their environment. With Dr. Jeff.
Alex.
Welcome to Labracazam, where we make science make sense.
Fossils are so amazing, and there's so much they can teach us.
That's right, Izzy. A fossil is the remains or traces of plants and animals that lived a long time ago, even millions of years ago.
Dr. Jeff, how do plants and animals actually become fossils?
Great question. Let's break it down. When living things die, they usually leave nothing behind, but sometimes they die in a watery environment and become buried in the mud.
Once buried, skin and muscle break down, leaving only bones or shells behind. Over thousands or even millions of years, sediment builds over the top and hardens into rock.
Then, something like erosion brings the remains to the surface, where scientists called paleontologists can dig them up and study them.
Too much work if you ask me. And no one ever asks me.
Fossils can be made either from the actual remains of a living thing,
Like bones, teeth, shells, or even leaves.
or they can be preserved records of a living thing's activity.
Like footprints, bite marks, or even poop.
Wow, so I leave fossils like that like 3 times a day.
TMI.
To dive into this a little deeper, I think it's time for a
Field trip!
Today we're visiting the La Brea Tar Pits, a fossil dig site located in the middle of Los Angeles. They have found over 1 million fossils here. To find out how they do it and what they learn about them, let's talk to my friend Laura, who's a paleontologist. That's a scientist that studies fossils. Zoe and Izzy here had some questions for you about fossils.
How do the animals get stuck in here?
Well, sometimes when that oil comes through cracks in the surface It makes sticky pools at the surface that turn into very sticky traps, and sometimes when the animals step in them, they get stuck forever.
Then you guys dig them up.
Yes.
Are there any special tools or special techniques that we use to find fossils?
You ever been to the dentist before? Your little dental fix that we use? That's the same tools that we use, actually. So we're there slowly, carefully working on your teeth. We're slowly working sometimes on fossils, just moving little bits of dirt, little bit at a time, so we don't break things.
So what does it look like when you find a fossil?
Well, actually, I could just show you. Come on. You can see all these little bumps here, all different fossils. They're all tangled up with each other. It's like playing a game almost, because we can't get that fossil out until we get that one, until we get that one, until we get that one. This I set aside for you guys. This is a bone from one of our most famous animals that we have here. So this is a thigh bone from an adult saber-toothed cat.
Awesome. Yeah.
So after you dig up the bones here, they go to the fossil lab where they're further cleaned and categorized.
Exactly.
Let's check out the fossil lab. After the fossils are found, they end up here in the fossil lab. And Bo here is their preparator. That means he prepares the fossils. Tell us about it.
So these are fossils that have come straight from the excavation. This is actually a dire wolf shoulder blade. So that's that bone right there. In the lab, we want to clean these fossil specimens. So what we do is we actually put it inside of a glass jar and then pour in our liquid that liquefies the asphalt off of these specimens. And then we'll pour it through a very fine mesh screen, and the liquid asphalt and the other material will come off and then look something like this. So this is a cleaned saber-toothed cat mid-backbone right here.
Cool.
Now let's learn what we can find out about fossils with the help of Dr. Emily Lindsay. She's a curator here at the La Brea Tar Pits. Hi, Emily.
Hi, welcome.
Thank you. What do you got for us here?
Well, so here we have two skulls of different animals that we find a lot of here at the La Brea Tar Pits. And one of them is a carnivore, which means it eats meat. And the other one is an herbivore, which means it eats plants. Can you guys figure out which is which?
This one has flat teeth to grind up grains, so it's probably the herbivore.
I think this one is a carnivore because it has sharp teeth. Looks like a hunter.
Good job. This is a saber-toothed cat, and as you can see, it does have these really long, sharp teeth that were probably used for catching or at least killing prey. This is actually a horse. And just like horses today, it's got really flat teeth that are good for grinding up grasses, so it's the one that eats plants. So you guys did great with that challenge, but now I'm gonna bring on one that's a little bit harder.
Bring it on.
So what do you guys think this animal ate?
Well, it has some sharp teeth.
Some smooth teeth as well.
We have sharp and smooth teeth too, so maybe it eats both like us.
Yeah, so this is actually a bear. It's a really big bear that's extinct now, called a short-faced bear, and in fact, like bears today, was an omnivore. And so it's got these big sharp teeth in front that are good for slicing through meat, and then it's got these nice big flat grindy teeth in the back that are good for crunching up berries and roots and all the plants that bears eat.
So what else can we learn about an animal from its fossil besides what it ate?
Well, we can learn all kinds of things, Jeff. So we can look at the size and shape of the skull and figure out how big the animal was. We can look at places where muscles would have attached and figure out how strong it was. We can look at the positioning of the eye sockets and figure out whether it was looking out to the side like most herbivores do or looking in front like most predators do.
That's amazing.
A lot of the animals they find at the La Brea Tar Pits are extinct. That means they're no longer found alive anywhere on planet Earth. To understand why some things go extinct and other ones don't, we look at fossils. Emily has some great examples.
So here are three animals that we find at the La Brea Tar Pits, and they're all cats. But two of these cats went extinct at the end of the Ice Age, and one of them is still alive today. Which one do you think made it?
I think this one made it because it's big and nothing can eat it.
I think this one looks like the best hunter, so it probably survived.
So those are both good guesses, guys, but in fact, this is the one that's still alive today. This is a mountain lion, and we still have it in Los Angeles today. These other two cats, while they may seem big and powerful, it turned out were not as good at adapting to the changes that were happening at the end of the last Ice Age.
So how do we know about the environment that these animals were living in 40,000 years ago?
So when most people think of fossils, they think of really big bones, right? But actually, there's a ton of information that scientists can learn from looking at the tiny fossils, microfossils or small fossils of all kinds of different plants and animals right here in the same places where we find the skulls of the big cats that we were just looking at. Do you guys want to take a guess at what some of these things are?
a little bone?
That's right.
Lizard
Yeah.
bones.
So these are all bones and teeth here that we have of little animals. So this is from a bird. These are teeth from rodents. We've got vertebrae from snakes and lizards as well. All of these animals got trapped in the tar pits along with the big mammoths and saber-toothed cats and giant sloths.
That one looks like plant material. Wait, are plants fossils?
Plants are fossils too, absolutely. Anything we have that's evidence of life in the past is a fossil. This is part of a leaf, this is a seed, this is some bark, and we get all of that preserved here, and that's something that scientists can use to figure out what plants were growing here and maybe what some of the animals were eating.
Wow, I never knew we could learn so much about the past just from looking at fossils.
Labracazam. Thanks, Emily, for this awesome field trip.
Thanks for coming.
Now let's see how fossils affect where you live. It's time to check out some real-world science. The fossils found in the La Brea tar pits show us what kind of extinct plants and animals existed in Southern California. And what about the rest of the country? Great Plains states like Montana have seen a large amount of dinosaur fossils unearthed over the years, including Triceratops, Velociraptors, and Tyrannosaurus rex. In South Dakota, scientists continue to dig at an active site that has the largest concentration of mammoth fossils in the world. And in northeastern Arizona is the Petrified Forest National Park, home to one of the world's biggest and most colorful collections of tree fossils. Over millions of years, the wood of the trees have turned into stone, preserving most of their outer structure. So even though they still look like trees, they're made of solid rock. We have so many fossils in our country that each state has its own designated state fossil. California's is the saber-toothed cat. Now, let's kick it over to Zoe.
Today, I'm going to show you how to make a model of a fossil at home. To start, you'll need modeling clay, plaster of Paris powder, water, a cold cup of coffee, a paintbrush, and your favorite toy dinosaur. First, flatten most of your modeling clay into a circular shape about ½ an inch thick. Then, take your toy dinosaur and press the side of it firmly into the clay. When you remove the dinosaur, it should leave a clear imprint on the clay. Now, you're going to cut away the excess clay and press it into the edge of your mold, making it into a bowl shape. For this next step, ask an adult to mix the water with the plaster of Paris. Once it's mixed, you can pour the plaster into the mold. After about 2 hours, the plaster will be set and you can carefully remove the clay. To make it look more authentic, you can let it dry 12 hours, then brush some cold coffee on it. You can switch your fossil with a friend. Use a magnifying glass to make observations about the plant or animal. Then make a claim and back it up using evidence from the observation. For instance, this guy has sharp teeth and claws, so I think he was probably a carnivore or meat eater. Try it yourself.
Thanks, Zoe. Now, let's review. Today, we learned that a fossil is the remains or traces of prehistoric life.
Many plants and animals that walk the earth are extinct, meaning they're no longer around today.
And fossils provide evidence about ancient life and their environment.
Hey, Dr. Jeff, check it out.
We found some fossils in Izzy's backyard.
Awesome, what'd you find?
I found a fossilized shell.
I found fossilized coral.
Neat, I want to go too. Join us next time on Labracazam. I'm Dr. Jeff.
I'm Izzy.
I'm Zoe.
I'm Bert.
Remember,
Always question, always wonder.
What do you think that is?
I don't know.
Alright, we're going to take a short break, go to the restroom, and then we'll come back and start back.